This image shows the 4 different eons of Earth, along with when it is likely that the current eon is going to end, which is 500 million years into the future. That time point is going to be covered a bit later. Each eon is characterized by different important events. The first one, Hadean, happened between 4.5 and 4 billion years ago. That is when the Earth was torrid with intense volcanic activity, along with frequent large-scale impacts. One massive impact even led to the formation of the Moon out of the debris sent flying from the impact. Despite the hellish nature of early Earth, during this time the oceans slowly started covering the surface of the planet more and more as the water levels started rising. The source of that water is probably a mixture, coming from the interior of the planet, along with water-rich asteroid impacts, and a bit of the source is from comets as well. Next is the Archean eon, that happened between 4 and 2.5 billion years ago. It is marked by the start of first life on Earth, simple single-celled organisms. Oxygen was certainly largely absent during this time, as the organisms that produce oxygen did not exist back then. The oceans were likely somewhat green due to the high iron content of the water. During the earlier periods of this eon, the planet from space also looked somewhat orange, as the indications are that it had plenty of hydrocarbons in the atmosphere. During this eon, dry land didn't exist to the extent that it does now, so the oceans covered an even greater surface area back then. Polar ice caps also likely didn't exist. The temperatures were a lot warmer than today, even despite the fact that the sun was fainter, and that is because of the greater concentration of greenhouse gases. Next is the Proterozoic eon. During this eon, the temperatures cooled down significantly, to the point at which, both at the start of this eon, at about 2.5 billion years ago, and at the end, about 650 million years ago, the Earth had a snowball period where either the entire surface was frozen, or most likely most of the surface was frozen, with a surface liquid water band around the equator. The evidence for snowball Earth events comes from the evidence for glaciers stretching very close to the equator. Between these snowball Earth events, the temperatures during this eon were broadly similar to today. The atmosphere slowly started accumulating oxygen during this eon because of cyanobacteria. By the late stages of this eon, oxygen reached about a few percent of the total atmosphere, which is less than the 20% currently present. The Proterozoic also had at least 2 supercontinents, Nuna in the earlier parts of the eon and Rodinia in the later parts around 1 billion years ago. Oceans started becoming a lot more blue by this point as well, due to oxygen reacting with the iron content dissolved in the oceans, which then formed deposits that settle on the seafloor. The hydrocarbon atmospheric haze was also lost during this eon, so Earth didn't look orange. The eon we are currently in is called the Phanerozoic. Although there are drastic differences within this eon, much more so than within previous eons, the key characteristics are pretty obvious. The current eon started about 540 million years ago with the emergence of a great variety of animals. Given that that marks the start, it makes sense that the end of this eon is going to be marked by the disappearance of a variety of animals, and that is predicted to occur at about 500 million years into the future. So let's visit Earth during this time. Although the exact numbers about the average temperature of Earth are far from certain, one thing that is pretty certain is that they are going to be a lot greater. This is so far into the future that the increasing energy output from the sun is going to have a significant effect, leading to average temperatures where nearly all of land on Earth becomes a desert. However, the reason for that desertification won't be entirely due to just higher temperatures directly alone. Rather, the higher temperatures at that point are going to cause a silicate weathering increase, where because of the greater temperatures, carbon dioxide reacts faster with silicates, which causes CO2 to be taken out of the atmosphere. Even despite CO2 being a greenhouse gas, and despite there being much less CO2 at 500 million years into the future, the solar energy output increase is still by this point going to lead to a significantly warmer planet. However, the lowering of CO2 is also going to lead to a mass extinction event of the majority of plant species. That in turn is also going to lead to a mass extinction event of the majority of land life. So by around 500 million years into the future, on Earth, most of land is going to be pretty barren with loose soil everywhere. That is going to lead to dust storms becoming a much more frequent and intense occurrence over continents. Potentially continent-wide dust storms could develop. However, during this point, there are still likely going to be some very efficient plant species that survive the drastically lower CO2 levels, but this type of vegetation is going to be sparse and won't be able to sustain a complex animal ecosystem similar to the one present today. Forests just won't be able to exist during this time. All trees are going to be gone by this point. Looking at Earth from space, the blue oceans in the atmosphere would still be there. However, the cloud cover over Earth is not going to be as prevalent. With that, rain is also likely going to be more rare, and on the barren continents, there are going to be significantly fewer lakes and rivers. There are ideas that during this time, Earth could also turn into a water world, meaning a global ocean could be present during this time with no land. That is because this is about the earliest time plate tectonics could stop, but this appears to be unlikely. Between 330 and 200 million years ago, there was a supercontinent called Pangaea. After that, it broke apart and became the several continents currently present. However, this cycle of where a supercontinent forms and then breaks apart occurred many times before Pangaea. So there were other supercontinents in the past cycles. It is plausible that there is going to be another supercontinent in the future. Potentially by around 250 million years into the future, given the past cycles, it is plausible that there is going to be another supercontinent. Then by around 500 million years, it could start to break apart again. But although it is certain that land formations are going to be vastly different 500 million years into the future, the specifics of that arrangement are still highly speculative. The movement of continental plates is still pretty hard to predict that far into the future. Polar ice caps during this time are very likely not going to exist. If due to land arrangements, there is an ocean at this time over the North or the South Pole, the temperatures simply won't be enough to form an ice layer even during winter time. And if there is land over one or both of the poles, then during winter, snow is possible. And then as the poles leave winter, that snow will just melt. Glaciers are at this point in the future likely a thing of the past for Earth, except for some really exceptional circumstances, such as if there is land close to the poles, and on that land there is an unusually tall mountain. As temperatures significantly drop with a significant elevation increase, that could allow for some relatively small mountain areas to have glaciers. Besides that, elevated regions could overall be the places where both plant and animal life is most abundant because of the more life-appropriate temperatures. Both animals and plants that survive this far are going to be small. Pretty much all energy and nutrient-demanding species are not going to be present on land. One big reason mountainous areas are colder is because at higher elevations the pressure is lower. But the interesting thing is, 500 million years into the future, the entire atmosphere of Earth is expected to have a lower pressure. One huge reason for that is because the majority of plant life is going to be wiped out. The oxygen levels are going to drop by quite a bit. Although plants on Earth don't contribute to the majority, they still contribute about 40% of the oxygen currently present. And given that phytoplanktons in the ocean produce the rest, and given that they are also going to decline in numbers, the oxygen could easily be half of what is currently present. The lower overall atmospheric pressure, due to the significant drop in oxygen, could also in a way counteract the effect of the higher energy output from the sun. But still, that very likely won't be to the degree that would allow for the planet to be anywhere as cold as it is today. However, the cooling effect coming from the lowering of the pressure could allow for life to exist on Earth in some state as well after 500 million years, with some estimates putting it at 2 billion years into the future. But these are simple life forms that could persist that long and not animals. The lower amount of oxygen is also going to make it a lot harder for fires to start. Along with that, the more sparse vegetation is going to make it very hard for fires to spread. So that is at least one survival benefit for the few remaining plant and animal species. The Earth has an axial tilt between 22 and 24.5 degrees that varies over a cycle of 41,000 years. By around 500 million years into the future, that range could expand by a bit, and the average axial tilt could be by about 1 degree greater, so the seasons should be slightly more extreme. This effect of a slightly greater average axial tilt is because of the Moon, which is going away from Earth. Another effect of the Moon moving away is that the length of a day on Earth is going to be around 26 hours, so about 2 hours longer. Looking at the Moon from the surface of Earth, it is going to appear just slightly smaller, but that is going to be barely noticeable because it is going to be just about 19,000 kilometers further away on average. This effect of a longer day, along with desert continents, is going to lead to temperatures over the continent likely having relatively extreme swings. The lower atmospheric pressure could further contribute to the extreme temperature swings. The temperature swings and high temperature during daytime are possibly going to cause for nearly all animals that are there to be adapted for life during the night when the temperatures are bearable. Interestingly, it is also possible that land animals could outlive plants. There could be some carnivorous ecosystems. This is, however, provided that the phytoplanktons from the ocean are still releasing enough oxygen into the atmosphere. The most likely location, then, for these unique land carnivorous ecosystems is potentially land close to the poles. So near or at the poles, there could be these small carnivorous animals that are mostly just active during the extremely long polar nights. What those animals would be like beyond that is hard to say. This is so far into the future that there could easily be a class of animals that currently doesn't exist. As for the ocean, it is pretty obvious it is going to be significantly warmer. They are not going to be as rich in nutrients because the flow of nutrients from the barren desert land is not going to be prevalent to any significant degree. The phytoplankton oxygen production is likely going to be on a decline. The oceans are also not going to be as rich in oxygen. The listed factors are going to make it significantly harder for large and active animals to exist, so animals such as whales or sharks are likely going to not be present. Just like on land, the animal ecosystems in the water are going to be likely simplifying at this point, though it is likely that the animal ecosystems and life overall is going to live on and fare for significantly longer in the ocean than on land. The nutrients are still going to be more abundant in the oceans for longer, and the temperatures are going to be far more friendly to life, given that unlike land, which quickly cools down and warms up, the water in the ocean is much less responsive to the energy output from the sun. The largest animal species are likely going to be in the water and not on land during this time. However, they aren't going to be as large and as active as they are today. Sluggish, large animals like jellyfish is potentially more what they are going to be like. The ecosystems present at truly extreme depths are probably at this point just going to consist of microscopic organisms, as these ecosystems are already not that varied and they rely heavily on the nutrients coming from the upper parts of the ocean, and those nutrients are going to be much more scarce. Potentially this far out, given the constantly moving nature of plate tectonics, there could be depths that form that are even greater than the Mariana Trench. Whatever the case, the layout of the ocean floor is certainly going to be different during this time. The Earth existed for 4.5 billion years, and it is likely going to exist for at least another 7.5 billion years, at which point it is somewhat uncertain if the expanded red giant sun is going to swallow Earth. So during a timeline of 12.5 billion years, only about 1 billion of those years is when complex life is abundant on Earth.